Welcome, everyone. Oh my gosh, what a great afternoon we're going to have of fun and some really informative learning. I know that I'm really excited, and everyone from the RunningBrooke team is really excited to be here with you today, to share and learn with you today, so we can spark happier, healthier, learning-ready students across our city and beyond. So again, welcome. For those who don't know me, I'm Brooke of RunningBrooke, the founder, an organization that I founded 10 years ago as a new mom. And running at that time peeled off layers of anxiety I think I had and didn't really know it. So maybe it's a little bit of depression, but I just knew it made me a happier mom. 10 months ago, being physically active literally let me survive a brain aneurysm. That's per my neurologist. So here I am 10 months later after nearly not making it. And then all the time in between, being physically active gave me and gave the RunningBrooke team and staff all the things that we needed in order to build the organization. So, that focus that we're talking about, the fortitude, the tools, that's now helped tens of thousands of kids across the city get moving with programs, with playgrounds, and with partners. So at the time when we got started, we didn't understand the science behind the physical activity. We just knew it made us feel better. And so now, 10 years later, here we are with you sitting with literally the leaders of this, the best of the best here for today. So how exciting is that? And I know that together we're going to understand and we're going to build and we're going to grow and bring these benefits of physical activity to our kids. So we're talking about brain function, we're talking about heightening learning, we're talking about increased in-classroom on-task behaviors, classroom cohesion, as well as reduction of ADHD, depression, and obesity. So we hope that you not only leave with the tools that you need, we know that you will, behind the science, but the tools that you can immediately use in your classrooms and in your spaces tomorrow. So before we get started, and I'll introduce the speakers in a minute, but before we do, I wanted to recognize our Summit supporters and our RunningBrooke supporters, the Brune Morris Family Foundation, of course, Alexandria City Public Schools, the Liz Luke team, 6 Half Dozen, MGAC, McLaughlin Ryder McLaughlin Ryder Investments, Reborn Fitness, and the Wise family. And I know we have a bunch of community leaders here as well, kind of stopping in and out as they can and swinging by. From City Council, our new mayor, Justin Wilson, our Vice Mayor, Elizabeth B. Parker, Bennett Parker will be joining us. I know Councilman John Chapman is coming, and our great former Mayor, Allison Silberberg, is here. Yeah, here's Allison. Have I missed anyone? I don't want to miss anyone that's joined us. So for our school board chair, our new school board chair, Cindy Anderson, is here. Yeah, Cindy, thanks for joining us. I know Margaret Lorber is here as well. Margaret is here. And Christopher Suarez is swinging by. Anyone from the school board I might have missed? All right, and then our Alexandria City School Superintendent, Dr. Hutchings, has come by and met the speakers. He says to say hello. He left his team here to learn more. And former superintendent of Falls Church and former interim superintendent of Alexandria City Public Schools, Dr. Lois Berlin, is planning on coming. So thank you all for all you do. So let's just get right down into it in the day of logistics. Well, as you know, we have a great program for you, and I'm sure you're quite familiar with everyone's bios. If you need to look back, they're in your program, and you can read up there. And it was personally difficult for me to, really convey just how mind-blowing our speakers are. So I'm not going to try. Just know that we're in for a great afternoon, and the best afternoon of incredible learning and fun. Our keynote speaker, as you know, is Dr. John Ratey, and so he's going to be here as soon as I'm done. I'm going to invite John down. and he'll speak until about 5. From 5 until 5:15, we'll have our first intermission. We'll have snacks and facilities outside. We're going to come back to this space for our first breakout session. So in this room will be Mike Kuzala, Kinesthetic Classrooms, if you want to learn about that, the teaching and learning through movement. So if you want to hear Mike, this is where you are. If you want to learn about Paul Zantarsky, the Learning Readiness PE, many people might know of him from Spark. His session, the application of neuroscience in school setting, he'll be just across the way there. And then what will happen is both breakout sessions will be the same. So if you want Mike, you're here. If you want Paul, you're there. So the breakout sessions will be for the first one from 5:15 until 6. We'll have our second break outside for food and facilities. Our second breakout session will start our second round will start at 6:15. So we'll come back in, and that'll go until about 7. I'd be remiss if I didn't, thank ACPS for the facilities and for all the help that they've had today, and 2 special people here in our audience, Kurt Huffman and Mike Humphreys. You guys are amazing. Couldn't do it without you, and so, yeah. And so if you help us by thanking the staff as well. And so now, please join me in welcoming our keynote speaker, Dr. John Ratey.
Can you hear me without the mic? Yes. All right, good. I'll try to keep my voice up. But first off, I want you to all stand up. I always debate with myself whether I'm going to do this or not, but I always end up doing it because it's a good way to start the meeting. Okay, put your hands out in front of you like this. Pull them all the way back real tight. Bend down and touch the floor. Let's do that again, one more time. Pull it in real tight, bend down and touch the floor. Actually, about 6 more times. Pull them back all the way and then bend down and touch the floor. Pull them back all the way, that's right. Pull them back. Okay, one more time. Pull them back all the way. Touch the floor. Okay, good. Great. So what you did is you got your major muscle groups moving. And what that accomplished is you turned your brain on a little bit more than it was before. And that's what my talks about, what my book's about, how exercise and play make for the best learners. We knew I'm a philosophy major and philosopher all my life, and Plato and Aristotle and Greece are my second home. And Plato said it well, that there are two parts of success in our lives: education and physical activity. He wrote about it 300 years BC and said we needed to do both. And when we do that, we now know that we create a big change in our brains. We make our brains different by moving. And that leads to regulating our emotions. I'm a psychiatrist, and that's part of my interest in it from the beginning, and optimizing cognitive function, optimizing our brains to learn, to remember, to attend, to be better at picking up information, sorting through it, and dealing with it. And so my emphasis has been on getting our kids to get moving again. And this is a big problem today, especially with social media, especially with the phone, the computers, all the Fortnite and texting and checking on things. Just think about, we're talking about it all the time, how addicted we are to our cell phones. So I'll give you a little hint. One of the reasons we're so addicted to them is when we check our phones after this meeting, you all will, you're getting a little bit of dopamine squirted into your brain right at the reward center, because you're looking to see whether you're still relevant, whether you're still loved, whether you're hated, whether people still remember who you are, even if you got spam. So this is what we do, and it takes away from our moving in the world. Well, in the late 80s, actually, there was a big study all over the world looking at what prevented the onset of cognitive decline in Alzheimer's disease. They were beginning to worry about the aging population in the world, because we were getting healthier and being able to stay alive longer. So they did this big study, MacArthur study, looking at about 15,000 people and following them over years. And what they found were 3 factors that prevented the onset of cognitive decline in Alzheimer's disease. The 3 factors were ideal weight, continuous learning, and exercise. And even when they factored out the exercise positive effect on blood pressure and pulse and cardiovascular improvement, exercise was still the most, what we call, robust factor. Had the most important effect on keeping people from developing dementia. So one of the scientists came back to his lab in California at University of UC Irvine, Carl Kottman, and he said, I'm going to check out, why does this happen? Why is exercise so powerful? We sort of knew about the first 2 factors, but exercise. So he got a bunch of mice, and he trained them very quickly to run in these running wheels. And before they began, he did the mice SATs on them, right? And then he taught them to run, left them alone for 10 days or 2 weeks with the running wheel in their cages. And they averaged running 4 kilometers a night, which is a long way for a little mouse. And why were they doing this? They liked it. They liked doing it. It was self-rewarding, so they kept spinning those wheels. After the study, they tested them again. Their scores went up about 50%. They got 50%. Their SAT scores were better. Then they also looked at their brains. And what they found is when they opened them up and saw what their brains looked like, the top part of their brain, the very top of their brains, were thicker. They were more connected. There was more connections amongst the nerve cells. Then they weighed the brains, and their brains were heavier than a comparative group, their brothers and sisters who didn't run. Their brains were heavier, and they measured this one substance called BDNF, brain-derived neurotrophic factor, which we had just discovered back in the mid-'80s as something that we call the miracle grow for the brain's fertilizer. It keeps our brain cells young, it keeps them growing, which is what they have to do, and it keeps them from being eroding, which is what happens as we age and stop using them as much. This BDNF became a very, very big deal, partly when this study was published in Science in 1995. That was the beginning of a revolution. Neuroscience was saying, hey, exercise is really important. We have to start looking at this. And so studies went on and on and on. And so we learned a lot about BDNF, how important it is, how much it makes our brains work best. Now we know it's an antidepressant, it's an anti-anxiety agent, it helps with cravings, so it helps with addictions. And it certainly helps keep our brain cells clicking, keeping ourselves from eroding. And a lot of research is being done continuously, right? One of the questions that everybody of all audience seem to ask all the time is weight training or strength training as good as aerobic training? Well, in fact, more and more studies are showing that all activity is good for the brain. All activity involves the brain cells, which is what we really need to do. So, for the longest time, we could measure mice and rats running and look at their brain differences, but we didn't have any weight training for them. It was hard to get them to do presses and also very difficult to get them to do a yoga pose. But today we're bridging that gap and learning from humans as well as from animals and doing various kinds of things, including strength training, believe it or not. Well, anyway, what happened after this study is that neuroscience departments around the world said, whoa, this is really important. This is one thing we can do that has a positive effect on our brains. So this is a picture of looking at the amount of studies having been done on exercise in the brain in the scientific literature. That is, completed studies that looked at how exercise was impacting our brains. Very, very many departments look at it. Whole schools are devoted to understanding what exercise does and why does it do that. The big push initially was on preventing aging brains, preventing cognitive decline, preventing Alzheimer's disease, such that in 2011, the Mayo Clinic's Department of Neurology, very hardcore people, did a look at 1,600 papers, 1,600 scientific papers that had been published in the previous 10 years, looking at exercise and its effect on the brain and cognition. Mainly looking at the push was to prevent Alzheimer's disease, to prevent aging and losing brain function. What they found was it was enormous. There was no question about it. The studies were universally positive that exercise improved cognition, improved the test scores on everybody, and also was a good way to prevent our brains from eroding. This slide really captures it. It's a slide out of Illinois, looking at a bunch of 69-year-olds who were all sedentary, 100 of them. Half of them they began to bring in and have them run on a treadmill, walk and then run on a treadmill for 30 minutes 4 times a week. They did the elderly SATs before. 6 months later, they did the SATs again, and their test scores went up 15%. But then they also measured their brain area by using MRI scans, more primitive back then in 2006, 2004, when they did this study. But anyway, they did it before and after, looking at the brains, 6 months of training on the treadmill, right? So what they showed in these areas here, the blue and the yellow areas, are areas of brain growth. So when they began to move, their brains grew. So they showed the same thing that Carl Kottman showed in those little mice. So the elderly persons, which now I'm a member, get their brains bigger if they're moving. And this then led, as I say, to a lot of other studies. And we looked at this brain using the MRI scan in younger people. This is a group of 6th graders who they just did this test, divided them into two groups, if you were fit or non-fit. If you were fit, if you could run for a quarter mile or make a quarter mile. You were not fit if you couldn't do it. And then they tested them. The fit kids were a little bit smarter, about 11, 12%. But more importantly, already at the age of 10 or 12, these kids, the fit kids, had bigger parts of their brain. What we learned and what we were focusing on was an area of the brain called the hippocampus, which is an area of the brain that's sort of the way station, the grand central station of memory and learning. We knew that this was growing in moving animals. Well, in moving sixth graders, those that tended to move better had bigger hippocampuses already in sixth grade. They were bigger than their non-fit kids. Fit kids had bigger hippocampuses. And what does that mean? Well, that means that this has an impact on memory and learning. And then I learned about this school in Naperville, Illinois. I used to say it's 60 miles away from Chicago, but it's really only 35, that Paul Zindarsky told me today. That 35 miles west of Chicago. This school came to the fore to my attention in 2002, 2003, when they were on Frontline, because we were beginning to worry about the obesity crisis. And they did a whole Frontline on how obese we were becoming, how overweight we were becoming. And they had on Paul Zindarsky's partner, Phil Lawler, talking about what revolution he had created at the schools in Naperville, because they looked at all the kids in Naperville, 19,000 kids in their school district, this one year, and they looked at what their BMI and all this other kind of stuff was, and they found that only 3% of them were overweight. The average in the U.S. was 33% in schools. 3% to 33%. Today, it's 36% of our kids are overweight. They went to the two big high schools where there are 7,500 kids. They couldn't find one obese child. There was no obesity in this very large sample of kids. Well, that was stunning, but what really got me on an airplane to go to Naperville was the fact that some years before that, 99% of their kids took the International Science and Math test. And every country takes every 3 years. We usually come in the mid to low teens in the US. Well, they lobbied to take the test, which you could do as a country. So they were competing with all the countries in the world, as we always do. They came in number 1 in the world in science and number 6 in math. This, I said, is something. This is a revolution. So I flew out there and met Phil Lawler and Paul, and we fell in love. And I fell in love with Naperville and eventually wrote my book, Spark, which talks about what an amazing place this school was and led to, I think, a lot of changes in schools around the world. This is my book, this is my website, that's my Facebook page, and that's my dog. Was my dog. Passed. They age much quicker than we do. Anyway, I'll tell you about my dog. My dog is a Jack Russell. And I got the dog and I had to figure out, okay, what am I going to call him? So I went for a 3-mile run. And because when you're moving, you're more creative. I know that, and so I couldn't come up with what to call him. So I came back and I said, I got it. So I called him Jack. I took Jack to the pediatrician, to the vet. And the vet said, oh my God, you got a Jack Russell. He said, put him on Ritalin now. Because they all, as a breed, they have attention deficit disorder. Constantly moving, fooling around, causing trouble, but lovely. So instead of that, I developed an exercise program for him, which I'll share later. But anyway, this all led to my delving into why is exercise so potent? What's going on here? And I looked at our origins. I went back to the hunter-gatherer period and looked at how we evolved in terms of movement. Well, in fact, what I learned was we're all still hunter-gatherers. We have hunter-gatherer genes. The hunter-gatherer period where we grew our big brains and changed our genes to help and facilitate the growth was about 6 to 8 million years. We were moving, we were swimming, we were climbing, we were lifting. No one was training for triathlons, but we all were in shape. We all were athletic, because we had to be. We were moving on average from 10 to 14 miles a day, gathering, foraging, moving from one spot to another, chasing down antelope at times. We had to move. And of course, today we're not doing that. So during this period of 6 to 8 million years, we evolved our big brains, right? This is the motor cortex. And during that period of time, this part of the brain grew. And we added on more and more brain cells during that period of time as hunter-gatherers. Why? To help us be the best movers, to help us plan, to predict, to understand, to imagine, to remember. All the things that we as humans do better than any other species. And then, as time went on, as our groups got bigger, and after 10,000 years ago, when we began to farm, our social groups got bigger and bigger and bigger. Our language came in, and our brains took off, growing a little bit more. But what we use to talk with and to think with was our nerve cells that we evolved when we were only moving. So that which we call thinking is really the evolutionary internalization of movement. So during that time and throughout our evolution, we developed more and more brain cells that are involved with movement. So that when we move, when I had you do these, what's called the Hindu squat, when we did those squats at the beginning, you were using more brain cells than in any other human activity, because there's so much of the brain is involved with movement, with balance, with guiding our movements, with thinking about it, with planning, all the stuff we do automatically, but it's our brains that are very much involved. And now we know our brain is like a muscle, so that the more we use our brain cells, the tougher they get, the stronger they get. However, this is the problem. We're not moving. We're a sedentary lot. And we become more and more sedentary, and this leads, of course, to a lot of our current diseases. 85% of our disorders, our chronic diseases of today, are what are called lifestyle diseases. Diabetes, obesity, heart disease, blood pressure problems, a lot of the lung problems, and many of the cancers are caused or added to by our sedentary lifestyle. We're not moving. Now, I've written a lot of books about attention deficit disorder, and this is a picture of a typical ADD child. It says here, if you can read it, funny, he was here just a second ago. He's off and running. Well, that's similar to my friend Jack, I developed a very cool program for him. In the morning, I would take him out in the backyard, and I had 3 tennis balls. And we had a hill in the backyard. And every morning I'd take him out there, and he loved it. And I threw one ball up the top of the hill, and he went up and grabbed it and came down and shook it and showed me he had it. Well, terriers are bred not to drop anything. They pull the fox out of the foxhole. That's what they're bred for, not to drop. So he wasn't going to drop it just because I wanted him to. Then I had 2 other tennis balls. So I threw the second one up the top of the hill. He was transfixed. What is he going to do? Is he going to drop the one ball he had? Sure. So he ran up and got that, came back down, and then the 3rd ball went up, and so forth. So I would exercise him for a good 20 minutes or so to help his brain turn on. And then I could have him come in and do his work, because his attention system was turned on. And, he could take notes from me. Because they're very smart, too. The Jack Russells are among the smartest dogs. Anyway, there are times when I can't take him out, and he gets back at me. He can really be something. So what happens when he was running and when we run and when we exercise is that we fire away lots of nerve cells in our brain. What we call in neuroscience, we turn the brain on. We turn that part of the brain on. And especially, always, we turn the front part of the brain on. And people with attention deficit disorder have a problem with the front part of their brain. It's not switched on as much as it should be, as it needs to be. So when we use medication that works for ADHD, what we do, we use medicine that turns this part of the brain on. Well, exercise really switches this part of the brain on. It really feeds it, and over time it helps grow it. And this is the area of the brain that we call the area for executive functions. And this is really what we do when we're exercising. We're promoting our brains to do all the very human kinds of things like planning, predicting, organizing, putting the brakes on so we don't cause trouble, evaluating consequences, helping us maintain the focus. And this is an area where we have what we call our working memory, or a RAM chip. And what we know is over time, the more we exercise, the better we get at these functions, including getting a better working memory. Now, one of the icons of sport has been Michael Phelps, but he's also been a big icon for us in the ADD world, because Michael, at the age of 9, was the Energizer Bunny in the classroom. And so he was running around all the time. He needed to have something done. And it was bad news, because he was always not doing as well, getting into trouble, much like a Jack Russell. So his mom brought him to the pediatrician. The pediatrician said, we'll start him on Ritalin. He was on Ritalin for 2 years to help calm him down. It did okay, but what the real thing that really led to him really being okay was his mom also started him swimming. And by the time he was 11, 12, he was swimming 3 hours a day. And so both he and his mom decided, well, I'm doing okay, I don't really need my medicine, because he was swimming that amount of time. And I show this and talk about this because it's not just for his attention, but also for the problem that we see with ADD. Almost 3 to 1 people that are diagnosed with attention deficit disorder have problems with substance abuse. They have problems with alcohol, drugs, opiates, the whole gamut. They're much more prone to develop substance abuse problems, as was Michael, especially when he did not exercise when he wasn't in training. And now today, this is an old slide, Game Boy, a memoir of addiction, this is our big problem today, screen addiction. For all of us, but certainly for our kids. And one of the things that you'll see in the literature, what I see, is the effect of exercise on helping kids stay off their screens or limit them or balance it, because it certainly is an addiction. Well, Jack also had addiction problems. Barking, chewing Oriental rugs. The breed is known for their love of Oriental rugs. So I was always careful to tell the dog walker when I was away for the weekend, take him for a long run or a walk, get him moving. So this one weekend I came back and I found this. The dog walker didn't show up. So Jack got back into his addictive ways. And this is now a big emphasis today as we're looking at the opioid crisis. And I think also looking at the screen crisis that we're dealing with, where exercise can be a natural way to help prevent and treat our addictive problems. So anyway, with Spark and my going around and talking, I worked a bunch with Reebok, and we started this box program, BOKS, and we're now in 4,300 schools, elementary schools in the U.S., a bunch of schools in Canada and Japan and Korea as well. But Box is basically a program before school, a preschool program for K through 4. We have a curriculum, we have trainers, they train volunteers. It's all free. Go into a school and you train a bunch of people who are interested in doing this, and what do? They follow this curriculum, which is basically to get the kids to come an hour earlier before school to play vigorous games, tag, chase games, some calisthenics, fun stuff, interested, and where they're yelling and screaming and chasing one another in a very orderly way. And they do this for about 40 minutes or so. And then when we first started, we looked at the first 1,500 or so kids who were both inner city as well as suburban kids. And what we found were all kinds of positive, subjective responses. The biggest one that I focused on was that when we asked the kids, after 12 weeks of coming in 3 to 5 days a week, mainly 3 days a week, for an hour before school, would you want to do it again? Would you want to do it next semester? 96% of them said yes. They wanted to come in to play. There's this natural need for us to play, to be moving. They loved it. And what we have found with the Box program all over the country is that once it begins, it doesn't stop. It's something that sort of, as teachers and superintendents and people move on, a lot of times the programs go fallow. Not the Box program. It stayed, and we've hardly had any school stop using it. So it just points to the fact that we have this natural need to be moving. And not like this. This is, of course, the way we think about exercise and movement, making it convenient. Our lives are too busy. So this is an actual 24-hour fitness center in San Diego, California. It's real, not Photoshop. But it just points to the absurdity of the way we treat and think about movement and exercise. Something that we have to do, that we add on to our lives, rather than realizing all the benefits that physical education, physical activity, recess, activity in the classroom, which you'll hear about with Mike talking and with Paul talking, and extracurricular activity. They not only are they fun and interesting and keep kids involved, but they really improve lots of factors in the kids' lives. They feel better, they're less depressed, they're less anxious, they're more friendly, they're more loving, they're more lovable as well. Why? Because their brains have been changed by exercise. And we'll talk about that in a bit. So we know a bunch about what exercise does, how it works, how it changes our brains for the better. It increases our toughness of our brain cells. It increases the amount of brain cells that we have. That's why the hippocampuses were bigger in our exercising mice and kids. Their brains were bigger. They had more brain cells there because exercise promotes something that we learned about in 1999, something called neurogenesis, where we're making new brain cells every day. And exercise promotes that more than any other activity. So this revolution started with Naperville and started a whole series of interventions in schools. One of the first was this elementary school in Kansas City, Missouri, where they convinced the principal to start the day off in inner city school with an hour or 30 minutes of exercise in the morning, getting all the kids to run, to do calisthenics, to play vigorously, but to get moving and stay moving. What they found was they measured all kinds of stuff at the beginning, including the fitness gram, which is a way to measure how fit the kids are. Well, no doubt at the end of the year, the kids were much fitter on all the measures. But what was also exciting was that over the course of the year, there was a 63% drop in disciplinary referrals. That is, these kids were not causing trouble. They were not getting into trouble. They were doing better. They were more cooperative in the classroom. Even more impressively was a school in Charleston, South Carolina, where our friend Dave Spurlock had a school that was also an inner city school with very little resources. And they looked at a group of kids, grades 4 to 8, who came in every morning and had a 30-minute exercise play challenge where they had the kids play in certain areas for 12 minutes, or 8 minutes, 8 minutes. And they would do basketball at one station, at another they'd do double dutch, jump rope, another station, pogo stick, another station, they danced dance revolution, pogo stick. They varied it to keep the novelty there. And the kids all came in and did this. And what they found was after the first semester, during the first semester, compared to the semester before, the only thing different was this intervention in the morning, is that there was an 83% drop in disciplinary problems. The kids were not as antsy. The kids were not as like Jack. They weren't causing trouble. They were more compliant. They were more interested. They were more motivated. And so this, again, sort of supported the idea that our brains get turned on. And then we've started seeing data coming from all sources of looking at exercise and fitness in the schools. Big ones come from the state of California, where since Arnold Schwarzenegger was governor, he started to evaluate the kids, 1 million kids a year in California, on this fitnessgram in grades 5, 7, and 9. And they measured their level of fitness on these 6 different standards, fitness standards. And what they found are graphs like this, because in 5, 7, and 9 is when they took the so-called No Child Helped at All test that we began to test our kids with. And what they found was the more fitness standards the children met, the higher their test scores. And this is something that they've done every year, and see a graph very similar to this one, which was one of the first. That is, the more fitness standards the kids met, the higher their test scores in math and in language arts. Dr. Cooper, Ken Cooper, who started the word, who coined the term aerobics, way back, was a big person who developed the fitnessgram, and he got a whole bunch of donors in Texas to support this 1-year study where they evaluated 2.6 million kids in Texas 1 year and evaluated them on the fitnessgram, just randomly, boom, they did everybody. And what they found was the same kind of correlation. The fitter the child was, the higher their test scores, the better their grades, the less trouble they had with absences or tardiness. The more fit they were, the more extracurricular activities they participated in. Now this was in 2.6 million kids, and it was unrelated to sex, to race, to socioeconomic standing, which was really important, and even to the school that they attended. So even if you went to some of the poorest functioning schools and had better fitness, you were among the best students. So this is really should be motivating to us all. And a couple things, I don't want to just go on and on. But anyway, we're going to be talking a bit in the breakout sessions about movement in the classroom, or in fact, having the classroom move. Just how important that is to the kids. And there's lots of studies that have been done over the years, looking at brief periods of time, 4 minutes, 5 minutes, 10 minutes, and its effect on kids in terms of, again, using the marker test scores or grades. All that helps, that if they're moving, they're turning their brains on, and they're better. Some of the best studies have come from Europe. This one out of Germany years ago now, where they looked at a bunch of high school kids who were very high-performing kids. They did a series of tests. One, they gave them a test before they started exercising. They exercised for 10 minutes and retested them. Their test scores went up. They did the same kind of tests, and this time they increased their heart rate and made it much more aerobic, but also included some coordination skills, some challenges, coordination challenges. And those that had that added, they did better than just aerobics alone. So, which shows that, and basically, when you're doing coordination challenges and learning how to do things, as well as exercising, as well as moving your muscles, you're really challenging the brain. And when you do that, you really make the brain better. The ultimate, perhaps, is doing something like that. Aerobic, challenge your brain to move correctly or in the right pattern. Being with some other people, because that's a challenge to our brain, and doing it outside. That's more than a trifecta. That's whatever. It's so much more powerful because it really challenges the brain. And when you challenge the brain cells grow. They grow, they get better. You grow more neurotransmitter, you grow more receptors in the brain. Now, one of the things that we've learned and showed recently, we all know that it's true, that when you're walking or running, like I did with coming up with Jack as a name, right? You're more creative. So this study came out of Stanford now a couple of years ago, where they looked at about 150 Stanford kids, probably Psych 101 kids. They had to volunteer for it. And they tested them on a variety of different creativity scales. They came in and they were just sitting, they tested them. Then they went for a walk, they tested them again when they were walking. And then another cell tested them when they were finished walking on their creativity. What they found, when their expectation was that after walking they would be best, because their brains were turned on. But in fact, what they found was while they were walking, they were best. So somebody was talking earlier about a dancing meeting. The superintendent was talking about a dancing meeting. That's the best news. And what I say to people, everybody wants to know, okay, what's the best exercise?
Running.
What?
I said running.
It's good. Running is great, but it's nothing like dance. Very vigorous dance, especially if you're doing it right. Not the boomer dances like I do and embarrass my daughters, but dance where you're precise, moving with somebody, to music, changing. All those things demand so much of your brain. So dancing is sort of the one thing that has everything added to it. And if you do it outside, it's even better. So anyway, I'll close here because I don't want to go too far into everybody else's time. But this is one study, I think, that came out in 2009 after Spark out of Sweden, where the epidemiologist there, Maria Aberg, did this large study looking at over a 26-year period, looking at all the data from 1.2 million boys who were all tested at the age of 15 as they entered high school. And they were tested their aerobic function, their strength function, their cognitive function. And the girls were tested similarly, but the boys were retested at the age of 18 when they entered compulsory military service. And this is a big deal, because you have a 3-year difference. Well, what they found was that if the aerobic function got better, their test scores went up. Their IQs pushed up a bit. They were better test takers at the end if they improved aerobically, if they got more fit. This held for a million, I don't know how many, a whole bunch of brothers who were in the study, but it also held for, they had 600 sets of identical twins, 750 sets of identical twins, which is to an epidemiologist is gold, because you have the same genes. You look at the intervention, you say, oh, this is really different. Well, what they found was that if the twin that improved aerobically did better on their test scores than the twin who might not have improved, who stayed the same. So it held even for them. So it's sort of clear that this is proof that exercise has a way of, because we're using so much of our brain when we're moving, that it helps our brain grow and get better. And I'll quickly talk about, I can talk forever, so, but I'll just quickly talk about the effect on emotions, because it's important for our kids and for all of us. We've known forever, really, in 200 BC, Hippocrates wrote about it, that his treatment for people coming in with depression was to sending for a long walk. They come back in and still depressed, keep walking. Keep walking. Well, we know that this really works. Duke University Medical School has been at the lead, looking at the effect of exercise on mood, on aggression, on anxiety, from the early 80s, really. They began to study it. We all knew that it was true, that exercise made us feel better and made us less depressed. But they started this whole series of studies looking at exercise and its effect on mood. And so they ended this in 1999, published this one study where they looked at 100 patients who came into Duke with the complaint of depression. All of them were sedentary. So they divided them into 3 groups. One group they had beginning exercise 3 times a week for 40 minutes, getting their heart rates up to 75%. Another group they gave increasing doses of their antidepressant, Zoloft, until they achieved success. And another group they did both. They did both Zoloft and exercise. And what they found at the end of 4 weeks is that all the groups were the same. They had all become undepressed. And at the end of 4 months, that held. But this was heralded as a way to say, well, exercise was as good as our antidepressants in treating depression, in treating mood. Well, this was challenged by the psychopharm people, by the biotech companies, saying, look, you didn't have a placebo group. So 10 years later, the same group at Duke did another study where they added a placebo group. Similar kind of study, only they did 2.5 times as many patients. And they found the same result, that exercise was as good as an antidepressant to treat depression. So we know that it improves mood. We know that now it prevents people from getting depressed. It prevents people from dropping down into the hole of depression. And also, we're learning about how it works. One of the things that we're learning is that it changes our brain cells. It changes what kind of brain cells we have in this area of the brain called the hippocampus, which is about memory and learning, but it also controls stress, anxiety, response to environment, because that's where most of our stress hormone binding sites are in the brain. So what we found is that with exercise, we change the kind of brain cells we have in this hippocampus, where we add on more brain cells that contain a substance called GABA, which is the major neurotransmitter that's an inhibitor in the brain. So it helps put the brakes on our over response to threats from the environment, which is a cause of stress. So with exercise over time, we create more of these GABA cells, which put the brakes on. And then to close, they did the sort of obverse of this study, where they got a bunch of kids that were very active and had them not exercise for a week period, and then measured their anxiety as they didn't exercise. And they found that their anxiety scores went way up. So the exercise was keeping them, or when they took it away, that there was a withdrawal effect, that they had a problem with their anxiety and controlling their anxiety. So all in all, there's so much evidence out there, and it's accumulating at warp speed on the fact that exercise and movement in general, activity in general, has an effect not just on our bodies, not just on making us buff or helping us lose weight, but it has a tremendous effect on our brains, keeping our brains functioning, helping our brains to remain in a state of equilibrium, and giving us, teaching us that we can do it. I mean, there's all these psychological aspects of it as well. We develop grit so that we can work through difficult periods in our life, and also that it helps us with motivation. It helps us be more motivated for life. So with that, I'll stop and